One of the real issues I've been running into lately has to do with onboard switch mode power supplies. And some products may have up to 4 of these small ICs driving various voltages required for the microprocessor and RAM and possibly the FPGA. And what I'm seeing is ringing on the switched waveform like you see here. Now this is a 1 megahertz buck switch mode converter on a sample board, and we're measuring it with the Keysight Technologies MSOX3102A oscilloscope. It's got a 1 gigahertz bandwidth, and we're probing with the N2976A 2 gigahertz bandwidth active probe. And notice the ground return is very short on this probe. That's one of the keys for high frequency measurements. And you can see quite a ringing here. Let's expand that a little bit. Okay, and I've got cursors set, and we can read out the ring frequency, which is approximately 240 megahertz. And the peak voltage here is about 17 volts that we're measuring. Now I'm also measuring the common mode currents in the power leads here using a Fisher F33-1 current probe. And we're measuring the common mode currents using the Regal DSA 815 spectrum analyzer. And what I have here is the yellow is the ambient signal with no connection. So that's basically the noise level reading. The violet trace here is from the current probe, what we're measuring. And you can see there's a very broadband noise generated all the way up to a gigahertz. Now we're looking from 10 megahertz to a gigahertz, and you can see the emissions are largely broadband, as we've mentioned in the past. And I have markers at 240 megahertz. You can see there's a resonance here at 240, and that's pretty characteristic of the ring frequency. The ring frequency will very often cause a resonant bump here. Notice also the second harmonic of that at 480 megahertz, and 720 megahertz is the third harmonic, and 960 megahertz is the fourth harmonic of this ring frequency. Now the problem that I see recently is that all this broadband noise is getting into the product's receiver. More and more products are incorporating wireless, and so all this broadband noise is getting, right here is one of the telephone bands, and that broadband noise is causing receiver sensitivity issues, so that it makes the receiver part of the modem non-compliant as far as the various carriers like Verizon, Sprint, and AT&T and so forth. They have very strict requirements on receiver sensitivity. And all this broadband noise is starting to get into the various wireless bands, and that's not a good thing. So what this is going to require is very strict layout on the printed circuit board and good filtering to eliminate this kind of ringing.